talking a little bit more about functions and how we can describe them here. Increasing, decreasing, and constant. Well, this is basically exactly what you would expect it to be. Increasing is when the graph is going up to the right. Decreasing, it's going down to the right. And when it's constant, it's not going up or down. It's horizontal. So an example here, where is this graph increasing? And we are assuming that there are arrows on here. So it's increasing from left to right, from infinity or negative infinity, up to about -1. So increasing from negative infinity to -1. Notice I used a parenthesis there. This is important. We're not including the point at -1 in increasing or decreasing because you can't increase or decrease at a point. Okay, the point itself is going nowhere. So we're increasing up until that point. And then there's more increasing on this graph, starting at about 1 and going up to infinity. So we'll union that with 1 to infinity. Then where this graph decreasing from left to right, from about x equals -1 to x equals 1. So -1 to 1, again in parentheses, writing this in interval notation. Next, what's a relative maximum and a relative minimum? Well, a maximum is the highest most point on the graph. A minimum is the lowest most point on the graph. Relative means with respect to everything else. So in a smaller interval, where do you have a maximum or a minimum? A maximum being the top of a hill, a minimum being the bottom of a valley. So if we look at this picture, again, assume that there's arrows there, then there's not a maximum because it keeps going forever. There's not a minimum because it keeps going down forever. But there are a relative maximum and a relative minimum. The relative maximum is just somewhere on the graph where we hit a maximum point or the top of a hill. So this would be the point -1, 1 approximately. So there is a relative maximum at x equals -1, which is the point -1, 1. There's a relative minimum at x equals 1, which is the point approximately 1, -1. And it's pretty much, that simple. There's no constant on here because that would be a horizontal part of the graph, and there's none of that there. And then the last part from this little section is even and odd. How do you tell if a function is even or odd? In an even function, f of -x is the same thing as f of x. So let's look at a picture over here. This first one is an even function. So basically an even function reflects over the y-axis like this. An odd function, if f of -x is the same as negative f of x. What does an odd function look like? It looks like this last one here, where this point will flip down there. That's an odd function. So how do we figure this out algebraically? H of x is equal to x to the 5th plus 1. So we first need to find h of -x. Now what does that mean? It means wherever there's an x, you put in -x. If we do that, -x to the 5th That's an odd power, so we end up with a negative x to the 5th plus 1. Now, so our question is this the same as this? And no, it's not, because we've got a negative here and a positive up there. So that means that this is not even. This function is not even. Then, to help us figure out if it's odd, we find negative h of x. What does that mean? That means take the whole function of h of x and make it negative. So we're just going to distribute this negative through here. And then we ask ourselves, is this function or the same as this one? Okay, that's what tells us if it's odd, if h of negative x is the same as negative h of x. And they're not the same. So it is not odd. So we can say that this function is neither even nor odd. If you look at the graph, you can see why.